Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Standard Level Paper 2 May 2021 Time Zone 1. If you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. And let's get started. Iron may be extracted from iron 2 sulfide FeS. Outline why metals like iron can conduct electricity. Because it has delocalized C of electron. These are the regular arrangement of metal. Okay, it has positive charge for this atom and it has C of delocalized electron. Okay, because of the C, delocalized C of electron, it makes metal able to conduct electricity. Justify why sulfur is classified as a nonmetal by giving two of its chemical properties. Nonmetal, it able to form acidic oxide, while metal like group 1 and 2 will form basic oxide. Also, it forms anion by adding electrons for non-metal, but for metal, cations, positive ion. And also it forms covalent bond with other non-metal by sharing electrons. Iron 2 sulfide FeS is ionically bonded. Describe the bonding in this type of solid. It's electrostatic attraction between oppositely charged ion between Fe2 plus and S2 minus, or metal with non-metal. State the full electron configuration of the sulfide ion. Sulfide with electron number is 16 because of proton number is 16, and sulfide comes from group 6 that able to add 2 electron, so the charge is -2. Everything comes from group 6, it has -2 charge, so the electron becomes 18. So now the configuration electron becomes 1s, 2s2, 2p6, 3s2, and 3p6. Outline in terms of their electronic structures why the ionic radius of the sulfide ion is greater than that of the oxide ion. Oxide ion and sulfide ion, both of them comes from group 6. Therefore, the charge is 2 minus. Number of proton of oxygen is 8, or atomic number is 8, so number electron also is 8, so now total becomes 10. And for sulfur is 16, so now becomes 18. So the electronic structure are 2 and 8, and this one 2, 8, 8. Okay, so it has 2 shell, and then this one 3 shell. So therefore, electrons further from nucleus or sulfur sulfide ion has an extra shell. So the ionic radius is bigger compared to the one that has 2 shells only. Suggest why chemists find it convenient to classify bonding into ionic, covalent, and metallic. It allows them to explain properties of different compound or make prediction. For example, NaCl when it's soluble in water, it able to conduct electricity because there is electrostatic attraction, right? And for ethane, because it's covalent bond, so the boiling point is low. So having them to classify into ionic, covalent, or metallic allows chemists to predict what happens with this molecule or bond in the molecule. The first step in the extraction of iron from iron 2 sulfide is to roast it in air to form iron 3 oxide and sulfur dioxide. So Fe2 plus because iron 2 and sulfide ion, so sulfide, yeah, so that would be FeS solid, react with something, okay, react with something, produce iron 3 oxide. So crisscross, it will be Fe2O3 plus sulfur dioxide. Okay, to roast it in air, it means it must react with some gases in air. But when you see here, it's oxygen. Therefore, the gas, some gases in the air, it's oxygen. So you just need to balance them. All right. Deduce the change in the oxidation state of sulfur. The reaction is FeS plus 7O2 produce 2 Fe2O3 plus 4SO2. So sulfur here will be -2 Fe plus 2, and this one -4 and plus 4. So from -2 to plus 4, or the change will be plus 4 minus -2, so plus 6. Okay. Suggest why this process might raise environmental concern, because SO2, when it dissolves in the water, will cause acid rain. Explain why the addition of small amounts of carbon to iron makes the metal harder, because it disrupts the regular arrangement of iron atom, and it prevents layer of atom to slide over one another. In the case of iron, okay, it has a regular arrangement. So one of the properties of metal, it can be hammered into a shape or malleable. So this because there is a layer of the metal that has a regular arrangement can slide over one another because the size of atoms are all the same. But in case adding carbon, now the size of atom, there is big and then there is small, there is big, there is small. The small one, for example, it's assume it's a carbon, and then the big one is iron. So now it's not regular anymore, so it has a different radius, so it will stop layer from sliding over one another. Therefore, it makes it harder compared to only iron. Iron 2 sulfide reacts with hydrochloric acid to form hydrogen sulfide H2S. Draw the Lewis electron dot structure of hydrogen sulfide. Okay. Predict the shape of the hydrogen sulfide molecule. It's bend or V shape. In aqueous solution, hydrogen sulfide acts as an acid. State the formula of its conjugate base. So hydrogen sulfide, when it reacts with water, will form HS minus and H3O plus. H2S will donate the proton, so it means it is acid, and accept proton, it's a base. Therefore HS will be conjugate base, and this one conjugate acid. So this is the answer. Saturated aqueous hydrogen sulfide has a concentration of 0.10 molar and the pH is 4. Demonstrate whether it's a strong or weak acid. If we calculate the pH, concentration of hydrogen sulfide is 10 to the power negative 1. So pH will be negative log 10 to the power negative 1, which is 1. So 1 is for strong acid, but the pH is 4. Therefore, hydrogen sulfide is a weak acid as the pH is higher. Calculate the hydroxide ion concentration in saturated aqueous hydrogen sulfide. If its pH it's 4, POH will be 10. So concentration of OH minus will be 10 to the power negative POH. So 10 to the power negative 10. A gaseous sample of nitrogen contaminated only with hydrogen sulfide was reacted with excess sodium hydroxide solution at constant temperature. The volume of the gas changed from 550 centimeter cube to 525 centimeter cube. Determine the mole percentage of hydrogen sulfide in the sample, stating one assumption you made. To calculate mole percentage of H2S, it will be volume that reacted divided by initial volume times 100. That would be 550 minus 525 divided by 550 times 100. That would be 4.5%. What about the assumption? Both gases behave as ideal gases. Ideal gases rules: they do not repel or attract each other, they move very fast, and they have no volume themselves, and they do not kinetic energy when they collide. Do not lose kinetic energy when they collide. So in conclusion, both of these gases behave as ideal gases. Magnetite Fe3O4 is another ore of iron that contains both Fe2 plus and Fe3 plus. Deduce the ratio of Fe2 plus ratio Fe3 plus in Fe3O4. For forming F3O4, FeO must react with Fe2O3. So the oxidation number, FeO plus 2, this one plus 6 plus 3. So as you can see here, there is one Fe2 plus and there is two Fe3 plus. Therefore, the ratio is 1:2 because there are one Fe2 plus in FeO, two Fe3 plus in Fe2O3. Iron exists as several isotopes. State the type of spectroscopy that could be used to determine their relative abundance. So it is only mass spectroscopy or spectrometry. State the number of protons, neutrons, and electrons in each species. This one proton 26, neutron also 26, and electron 54 minus 26, which is 26. And this one 26 and neutron. So for neutron here, I repeat again, 54 minus 26, and electron the same with the proton number. And for protons here, the atomic number, and neutron is 56 minus 26, which is 30, and electrons, it loses 3 electrons because 3 plus, so it becomes 23. Iron has a relative small specific heat capacity. The temperature of a 50-gram sample rises by 44.4 degrees Celsius when it absorbs 1 kilojoule of heat energy, 1000 joule, because the heat is in joule, so we need to convert it to be joule. So C equal to Q divided by M times delta T, which is 1000 joule divided by 50 times 44, which is 0.45 J per gram in Kelvin. In acidic solution, hydrogen peroxide H2O2 will oxidize Fe2+. Write the half equation for the reduction of hydrogen peroxide to water in acidic solution. So H2O2, hydrogen peroxide to water. Here O is 1, here is 2, so we can put 2 right here. So now H becomes 4 here, and here is only 2. We can add by adding H plus. So now the charge becomes plus 2 here, but here is 0. So we need to add electron, which is negative charge, to balance them. 2 electrons. So now it becomes 0, and this one 0. So it's the answer. Deduce a balance equation for the oxidation Fe2+ by acidified hydrogen peroxide. Okay, so from the first here, Fe2+ aqueous produce Fe3+ aqueous plus electron, and the second one 2 electron plus 2H plus aqueous plus H2O2 aqueous becomes 2H2O liquid. Alright, so we need 2 times 2 here, because here is 2 electron, here is 1 electron, so all of them becomes 2. And now we can eliminate the electron and you add them. So that would be 2Fe2 plus aqueous plus 2H plus aqueous plus H2O2 aqueous produce 2Fe3 plus aqueous plus 2H2O liquid. Okay. Hydrogen peroxide can react with methane and oxygen to form methanol. This reaction can occur below 50 degrees Celsius if a gold nanoparticle catalyst is used. The diagram shows the Maxwell-Boltzmann curve for the uncatalyzed reaction. Draw a distribution curve at a lower temperature, T2, and show on the diagram how the addition of a catalyst enables the reaction to take place more rapidly than a T1. Okay, when you find a curve that is slightly lower and then slightly to the right side, it means the temperature is higher. So we need to draw the lower temperature. It needs to be a bit up and down like this. Make sure that you don't touch the x-axis. So this is the lower temperature. The question asks you to show on the diagram how the addition of a catalyst enables the reaction to take place more rapidly than at T1. So this will be EA, and then this would be the one that with catalyst. Okay, so this EA with catalyst. Okay, so this part, it has a larger proportion of molecules with energy that is bigger or the same with activation energy. a lot more reactant can successfully overcome the activation energy. Okay. The hydrogen peroxide could cause further oxidation of the methanol, suggest a possible oxidation product. So it's a methanol. Methanol is a primary alcohol. So primary alcohol, which is methanol, when it is oxidized, will produce methanol. CH, so that would be CH, C double bond O, H, and then H. This methanol, and when you oxidize it again, it will produce methanoic acid. In case it's the secondary alcohol, when you oxidize, you will directly produce ketone. Methanol is usually manufactured from methane in a two-stage process. Determine the overall equation. So as you can see from this 2H can be eliminated. So only one H left. CO also can be eliminated. So now left with CH4 gas plus H2O gas produce CH3 OH liquid and H2 gas. 8 grams of methane is completely converted to methanol. Calculate to 3 significant figures the final volume of hydrogen at STP. Use section 2 and 6 of the data booklet. So for methane, mass is known. You can definitely calculate mole divided by 16.05, which is the molar mass of methane. You get 0.498 mole. From this equation, we can see the coefficient of hydrogen and methane are the same. Therefore, the mole of hydrogen is also 0.498. To calculate volume is N times Vm, molar volume. The mole is the same, and you just need to times 22.7 decimeter cube per mole. Then you will get 11.3 decimeter cube. Consider the first stage of the reaction. CH4, H2O produce CO and 3H2. Determine the enthalpy change. Delta H in kilojoule. Use section 11 is the bond enthalpy. I always like to draw to make sure that I don't leave any single bond to do calculation. Okay, so here we have 4CH, this one, this two. So that would be 2OH, produce C, triple bond O, and 3HH. So the number would be 4 times 414 plus 2 times 463, produce this one 1777 plus 3 times 436. So here would be 2582 and this one 2385. So delta H will be 2582 minus 2385. You will get plus 197 kilojoule. State the expression for Kc for this stage of the reaction. So CO and 3H2 divided by CH4 and H2O. So Kc will be concentration of CO times H2 to the power 3 divided by CH4 and H2O. State and explain the effect of increasing temperature on the value of Kc. It's an equilibrium reaction, okay? So let me just repeat again, write again the reaction. CH4 plus H2O, CO plus 3H2, delta H is plus 197 kilojoule. Therefore, this way will be endo because it's positive. This way will be exo. When the temperature increase, the equilibrium shift to the direction to take in heat or endothermic, because when the temperature increases, the energy is absorbed, so that endothermic. Therefore, it is forward reaction, because it's forward reaction towards the product, so Kc increases. If it's towards reverse reaction or favored reactant, Kc decreases. Okay? Ethanol is obtained by the hydration of ethene. State the class of compound to which ethene belongs. Alkene. State the molecular formula of the next member of the homologous series to which ethene belongs. Homologous series always plus CH2. So C2H4 becomes C3H6 because you need to add CH2. That is the homologous series. Justify why ethene has only one single signal in H-NMR spectrum. Ethene. It's symmetrical. So this H2 here are the same. So why it is only one, a single signal? Because hydrogen atom in the same chemical environment. Suggest two possible products of the incomplete combustion of ethene. CO, carbon monoxide and carbon, CO and C. A white solid was formed when ethene was subjected to high pressure. Deduce the type of reaction that occur. It is polymerization, because polymerization reaction is a reaction because of high pressure that can force ethene molecule to undergo a reaction where they can join together to form a long chain, which creates the polymer. When dinitrogen pentoxide N2O5 is heated, the colorless gas undergoes thermal decomposition to produce brown nitrogen. Suggest how the extent of decomposition could be measured. You can use colorimeter because it produces color, or you can check the change in color, or you can check the change in volume because there is gases produced. So when the gas is produced, you can also check change in pressure, one of them. Data for the decomposition at constant temperature is given. These are the data. Okay. The question is plot the missing point on the graph and draw the best fit line. So now we have only 4 data. The fifth one, it will be 24.30 and 0.7. So 24.30, so this is 24, so maybe around half, and 0.71, so right here. So draw the best fit line. You must have a ruler with you when you have exam, so it will be like this. Deduce the relationship between the concentration of N2O5 and the rate of reaction. As you can see here, these are the first order graph. First order, when you double the concentration, the rate of reaction will be double. 0 order, double the concentration, no rate of reaction will be changed. I mean, the number will be the same. But for second order of reaction, when you double the concentration, the initial rate or the rate will be quadruple. So now, to answer this question, the relationship between the concentration of N2O5 and the rate of reaction, doubling the concentration will double the rate or rate of reaction is directly proportional to the concentration of N2O5. Outline why increasing the concentration of N2O5 increases the rate of reaction. Because it has a greater frequency of collision as concentration increases. When the concentration increases, the amount of molecular atom will increase as well, and it will collide more, or the frequency of collision will increase. So the collision increases, of course, the rate of reaction will increase as well. Okay, that's all for the explanation for the standard paper 2, standard level paper 2, May 2021, time zone 1. I hope this video is helpful for your exam preparation and revision. Again, if you find this video is helpful, please don't forget to subscribe to support me, and let your other friend knows about my channel as well to support me. Thank you for watching, and bye.